I was told to sit in the dark spot because the focus should be on you. So,
okay.
we know who the important
We've got
one
good
is.
camera insurance, so I take it.
Yeah. So thanks for joining. Pleasure to talk to you today. On the way here, I was thinking, what would people want to hear from Martin in 2025? And I realised that if we don't mention Agile, AI, and microservices, they probably won't let us leave this building. So they're probably the things that we need to get started on. But before we talk about all of that interesting stuff, I always love to hear how people get into technology and what drove them to the area. Were you always passionate about coding and software systems? And what was your journey to get in there?
Well, I mean, a lot of my journey is finding the very, very few things that I'm actually any good at. I'm not one of these people who can, take their hand to anything and they end up being really good at it. I'm completely the opposite. So at school, I gravitated towards science stuff, particularly maths, physics, things of that kind, because frankly, my writing was terrible. I got lousy marks in English, lousy marks in anything that involved writing. So I clearly wanted a profession that had no writing in it. That was where I needed to go. So obviously that moved me into math, science and engineering. I like building things, but the trouble is I'm a complete klutz. I tried to, I failed woodworking because I couldn't saw straight. I tried looking after my car when I first had a car because it was an old crappy banger, because that was all that we could afford. And I struggled with it because I'm just not strong enough to get the rusty bolts off, and so that was a disaster. But the great thing about computers is you can build stuff without actually having any physical coordination or strength or anything at all, and you can still construct things. So I naturally moved into computing. I was also interested more generally in electronics. And then at university, I did electronic engineering with computer science because I thought that would be a good combo of things to do. But even though my maths is really good, the electronic engineering stuff was really, really hard, and the computer science stuff was really, really easy. The electronic engineering exams were 3 hours long, and the computer science exams were 2 hours long. So I naturally headed towards the computer science. So that's how I ended up in computers, because it's one of the few things I'm good at.
And you mentioned that writing wasn't one of your strengths, and you've happened to write a couple of books in your time.
My teachers would be amazed if they were asked, who is the person in your class who goes on to make a living as a professional author, which is effectively what I've become. They would have never guessed me. Never in their wildest dreams would they think it would be me.
That's amazing. One of the first things you did help write was the Agile Manifesto, and we've seen... No, not.
Well, it wasn't one of the first things. I mean, I'd already had a couple of books under my belt before I did the Agile Manifesto.
So my career started as, obviously a young software engineer and, self-taught, and then you go to uni, you end up in the workplace, and they make you do these things called stand-ups. And I spent a lot of time wondering, why are we doing this for? This doesn't feel right. Like, where's the value in this? And we see, and it continues today, like often we see stand-ups done very poorly, and it's just people going through the routine because that's what they feel they need to be doing. I'd like to hear some of your advice on how do people get it wrong, and what should they actually be focusing on, and what are some of the points that you would like to, tell this group of people that have probably sat through a lot of boring stand-ups before?
Where should I begin? It's a long story. And that's actually quite interesting to be asked this question in Melbourne, because one of the last, as you may know, I retired from doing public speaking. And I did that because I just found it too stressful. I was getting sick and tired of having panic attacks every time before I went on stage. This doesn't seem to bother me, but giving a formal talk really does. And so even though I was very good at it, I retired from it. But one of the very last talks I gave, probably the last original talk I gave, was here in Melbourne, in that trip in 2018. And the subject of the talk was basically Agile, how Agile had been going wrong and how we could deal with that. And you can find the talk if you go online. Do not watch the video version of the talk. Not just because you'll look at this ugly mug, but you'll also see this dreadful digitization picture behind me that kind of will burn your eyeballs out if you look at it. But it's okay to listen to because, I don't have any slides for that talk. But yeah, there's a whole bunch of things I talked about there. And if I was carefully prepared for this, I would have actually reread that and reminded myself what I said, because I'm sure I said it much better than I'm going to say it here now because I prepared for it. But off the top of my head, where I see one of the things that one of the things that we were most concerned about was the connection between technologists and business people. And you'll find that echoed in a number of places in the manifesto. In the value statement, we have this thing about customer collaboration over contract negotiation. And that's all about saying it's an ongoing process of continuous contact. We also said in the principles section that technologists, and I can't remember the exact phrasing of it, but it's something like technologists and business people should talk to each other every day. And it was interesting because we had quite a little discussion about the everyday part of that. I mean, we all agreed that we wanted to do it very, very frequently. But I said, well, every day, that's a bit kind of prescriptive. It's not always the best thing to do. How about just saying frequently? And those of us who were in favor of putting every day in there said, no, we don't want frequently in there because people say, yeah, every couple of months, that's frequently, isn't it? So, but we do mean every day. So if you're working on a software development project, you're one of the developers, any of the developers, in my view, you should be talking to some business person who is a user or beneficiary of your software every day. And if that's not happening, something's wrong. And unfortunately, it happens all the time. One of my most heartbreaking project visits at Thoughtworks was I was down in the Porto Alegre office. And we had a team of 4 of our developers who were doing a project for a client. The development team was 4 people. Their customer base was 4 people in America somewhere. It was a very important project. It was logistics planning for a retail outfit. There's only 4 people who used the software because it was that kind of very specialized software. They had never, ever spoken to each other. You know, this was the client's doing, not ours. I want to stress this point. The only way communication happened between them, and it was because the client had a scrum master, product owner, who handled all the communication. Except during the course of a year, they'd actually rolled over that role 3 times during the course of the year. I mean, I can't even imagine how stupid this is, right? But that happens, and it can happen to the best people. And those are the kinds of tragedies that we're dealing with. So the number one thing, I'm being very long-winded answer, aren't I?
No, I enjoy it.
Is well, you've got to say that, right? Is that customer collaboration. So if you're working on a project, think, how can I increase that customer collaboration? How can I go to lunch regularly with somebody who's the user or beneficiary of my software to understand what their needs are? Because in the end, what we're about is making our customers, as Cafe Sierra put it, kick ass, right? We want to make them really, really good at the job they're doing. And any software we provide is just a vehicle to help in that process. And if we don't understand what they do, we can't help them really do that thing. Then the next thing I would mention where Agile often falls down is people not recognizing the importance of technical practices. And this is, I partly blame this on Scrum because Scrum deliberately left all the technical practices out of Scrum. And they did so because they said, well, there's lots of ways you can do it, so we don't want to be prescriptive. I'm much more the extreme programming front. That what I loved about what Kent did with extreme programming is he put technical practices and the business communication both combined together. And this is crucial because you need the technical practices to learn how to write software so that you can pump out a very rapid rate. One of the key measurements of success in an Agile is how long does it take to get from in your head idea from the customer to in production. And you want to speed that process. If you're going to speed that process, you have to be really good at your technical practices. And the ones I recommend are absolutely the ones at the Extreme Programming Playbook because we know these work. This is what we do a lot at Thoughtworks. So it's test-driven development, it's continuous integration, it's refactoring, it's minimalist design, it's pair programming. All of these things are about making that speed. And this is where AI kicks in, right? Because AI can be a further accelerator. But it's only going to be an accelerator if you have the customer collaboration in place so that you're building the right thing quickly instead of the wrong thing quickly. Mm-hmm. But if you've got that high speed and you've got the customer collaboration, then you can really rock it.
So speed and quality, there's often a friction between that. And when we talk to business stakeholders as a technologist, and so we want to do it right, but it's going to take a little bit longer, or we need to refactor this thing over here.
Excuse me. Would never ever say to do things right, to do things with quality, it's a trade-off with speed or it makes it go slower, because that is not true. The point of the way I think of quality is, for a start, I like to separate external quality and internal quality. External quality is quality as perceivable to the outside. So the quality of user interface is an external quality feature. The pure internal quality feature is how good your code is. Is it modular? Is it well written? Things of that kind. Now, the thing about internal quality is that it is actually there to speed you up. The more modular your code is, the better your names are, the more attention you pay to minimizing coupling between the different modules, all these kind of things that we talk about, they're there to allow you to go faster. Because if I write a whole load of crappy code and you write some nice code, we might be able to have exactly the same product. Mm-hmm. But over time, I'll have a struggle to add new features to the code because I've got to constantly fight against what's going on inside my software. Well, you have sometimes been in that position where you can say, to add this new feature, I can take this, wire them together in a slightly different way, add a little bit of code in here, and boom, I'm out. And if you've had that environment where you can do that, where you can quickly supply new features by just slightly reconfiguring what you've already got, then you can make that rocketing speed. But you can only do that by paying attention to that internal quality. And as soon as you start even speaking out about, there's some kind of trade-off, you're in a trap. Because most people associate quality with high cost. Because if you want a better car or you want a nicer pair of shoes, you pay more. But the thing about internal quality of software is that that's not the case. That actually the high quality is the lowest cost. And that is a very counterintuitive notion. And so you've got to be really careful about how we communicate that because it is so counterintuitive. Now, there's an interesting borderline between external and internal quality, which is number of defects. Mm-hmm. And one of the things that always surprises people when they start doing an agile software development properly is they watch the defect count plummet. It is not unusual, and I still hear this when people say, we went into so-and-so client and we've gone live and we're an order of magnitude less defects in production than what they're used to. And that constantly astonishes people. But the point is that is an area where internal and external quality overlap, because by reducing the amount of defects, you're able to go faster, because the worst thing about defects is that it slows you down.
Thanks for that answer. You've spoken a lot about how we design these complex systems, and we deal with a lot of large, complex organizations, and over time, their systems grow like a big puzzle that's really hard to put together. No one really understands how it works. Loosely coupled systems is something you've spoken about a lot. We often see it done very poorly, or people adopt the wrong attributes of these things. What's some advice you can give people around how we architect these systems to be evolvable and helpful over time so we can maintain speed without being bogged down with legacy?
Well, there's whole books written about this topic, right?
I'll give you 5.
It's a combination. Again, we'll start with many of the key practices that we talk about in terms of software development. So one of them is, I think about it in terms of writing self-testing code. Mm-hmm. Now, the reason that that's important is it gives you the ability to change things and know what you've changed. If I make a change and I accidentally break something over here that I'm not paying attention to, the tests will come up and tell me right away. And if I pay attention to those, then that will give me clues as to hidden linkages between parts of my code that I can do something about. If I write the test at the beginning and I do the test first loop, one of the great things about doing that is it makes me think about these things up right at the beginning of my coding exercise. And that's the kind of the magic trick that test-driven development gives you. You think first about what you're going to do and separate it from the difficulty of thinking about how it's going to do it. And that twist around, that is so important because when it comes to modular design, one of the hardest things for people to grasp is encapsulation, about hiding implementation details behind an interface. I mean, I could talk about it in object terms. It's not just objects. Any kind of modular design has this notion of interface and implementation. And the thing is that when you're trying to solve a problem, you're focused on the implementation because that feels the difficult bit, right? The thing that makes it work. But having a test-driven design approach says, no, I've got to ignore implementation for a moment and think purely about the interface and about how I use it, the usability of it, and how it connects to other things. And only once I figure that out and have got that specified out in a fairly precise way through tests, then I switch over and put the implementation hat on. Mm-hmm. And that mental shift is, I think, one of the most valuable things about that technique. Mm-hmm. Then it's about, so that's the primary thing I'd point out as a kind of starting point. I would also put a lot of attention into learning about the various patterns that you can use and when you should apply them, because every pattern comes with this is the context where it's useful. Mm-hmm. And so it's important to know that kind of application as well. Then learning that, I can make a decision and I'm not bound to that decision. Because if I have that good testable base, I can change things. And what's more, I must change things. One of the rather annoying things about there's a strong culture in software development of the open source pull request culture that says, that comes from open source that says, I make a change, I give it to you, you review that change, and we go through a code review, etc., and then it goes in. And I mean, it's good that we're having a code review step. It's bad that people think that's the only place you can do a code review step. If you look at a well-functioning extreme programming team, they're always reviewing the code. Mm-hmm. Every time you look at you go into the system to make a change, you're code reviewing all the code around that change. And you're saying to yourself, well, that was actually the right thing to do 6 months ago, but now it's no longer the right thing to do. Okay, I'll change it. And that's the key thing, is realizing that, yes, you will change your mind and you should change the code when you realize it's no longer best for you. And if you've got a good basis of tests and you know how to do refactoring well, it's not difficult to change the code. But that is the key to then keeping things going, because you won't get the design right first time. Even if you were brilliant enough to come up with the correct design for the initial set of requirements, the requirements are going to change and go, hey, fooled you. So knowing how to refactor and how to change things, that's the secret superpower. But you can only do that if you've got the tests.
Yep. Modular design, you mentioned that. There was a big trend of microservices coming in and everyone wanted to make everything a microservice. We're maybe seeing a swing back the other way a little bit at the moment. What are your thoughts around the common traps that people fall into when they're moving from maybe a monolith to a microservice architecture? And what are some of the things or tips you could give them around that?
Well, I mean, the biggest trap is with microservices is thinking that they're always the right thing to do. It's interesting. If you talk to the people who originally popularized microservices, talk to myself, you talk to James Lewis, who wrote the original article with me back in 10 years ago now. If you talk to Sam Newman, who wrote the first book on microservices, they will all say, hey, we spend more of our time telling people not to do microservices than to do them. And that's because microservices come with significant challenges. For a start, I talked about refactoring earlier on. That's much harder with microservices. If you've got to move behavior from one microservice to another, that's a much harder thing to do than within a monolithic environment. So you've got to be careful with that and that's why a lot of people say, always try and build a monolith first and then look to break it out into microservices, because until you really understand the problem, you're not going to be able to make the right divisions. The other issue with microservices is that in order to get them to work effectively, you've got to have a pretty mature environment in other respects as well. So you've got to, for instance, you've got to make sure you can actually get your code and deploy it automatically and do this quickly. Because the whole point of microservices is you've got to be able to make these changes fast. So you need a path to production that's automated, that's fast. You're doing continuous delivery. You've got to have that down. You need to understand how, when microservices is in place, each microservices can be very well tested individually. And so you've got to be good at getting testing so that you have got that reliability at the individual microservice level. But you're still going to get interactions in production that are going to surprise you, because you can't easily get a whole glob of microservices into a staging environment. So what that means is you've got to be very good at your production monitoring and observability so that you can immediately see what's going on when things are in production, because production will surprise you. The only thing that counts is production. Charity Majors, what's her line? Only prod is prod. Everything else is an illusion. And that's true for all the staging environments in the world. So you need to make sure your production observability is high. So these are a lot of things that most organizations struggle with, but you've got to get those right in order for microservices to work. Now, where microservices become important is how do you organize a large team of developers? If you've got even 50 people, 100 people, how do you cope with that many people? And microservices is a way of organizing people primarily. It's a way of saying, no, we need to break into pieces that are independently deployable so that individual teams can make the decisions about putting out new features without having to coordinate with everyone else. And microservices have to be oriented around a particular customer activity so that we're focused on the customer. So we don't actually talk about the size of microservices in that original paper that James and I wrote. No point do we talk about that. Instead, the principles are all based upon this division of people, because in the end, that is what microservices are there. So if you're a team of half a dozen or a dozen people, you shouldn't be thinking about microservices, almost certainly, because you'll be probably better off with a monolith.
I wonder if there's the lessons, well, anyone who's tried to deploy microservices and maintain them know that it can get really hard and messy and the interactions can sometimes not go to plan. I wonder if the lessons we've learned around microservice could be applied to AI agents that are coming and the complexity that we're about to see in these non-deterministic machines talking to each other.
It's worse, right? Because you've got the non-determinism. So again, observability and proper observability, what Charity Majors refers to as observability 2.0, because she's so annoyed with people misusing observability, she decided to put a version number on it, which is kind of amusing. I'm rooting for her here because I understand the problem very familiarly for what happened to Agile and refactoring and object orientation and patterns, right? But yeah, observability becomes crucial. Produce lots of wide log telemetry. Listen to folks like Charity Majors and other people who understand observability properly, i.e. not most of the vendors that are selling observability solutions, because most of them don't, and use that crucially as part of AI systems. I've always felt that one of the most crucial things in an AI system is its explainability. Mm-hmm. No computer should ever be allowed to make a decision without clearly indicating why it's made that decision. If I would argue about regulations and things, I wouldn't regulate on the basis of whether it's algorithmic or not, or whether it's AI or not, all that kind of stuff. That's kind of interesting, but that's actually not the crucial point. The crucial point is, can you justify your decisions? And that's the crucial thing. And if you're throwing an AI into a system and it can't explain its reasoning, then I'd be very, very concerned.
We've seen software be used to transform many industries over the years. Now software itself is being transformed by AI, which I find hilarious. Mm-hmm. And we're grappling to deal with that, just like how many industries have grappled to deal with the new business models in their industry. How are you seeing people adopt AI tools in their software development lifecycle? And what are the things that are working and what are the things we should perhaps avoid for now?
Well, I'd say the most important thing to remember is it's still very early days. It feels weird saying this to Andy because he knows way more about this stuff than I do. I should really ask him the question.
They're here to see you, though.
I'm just trying to remember all the things I've heard Andy say over the last few days that we've been together, and I'll parrot it back to you, basically. So you tell me when I've got it wrong. Okay. So the key thing is it is early days. We are still learning about what to do. I have the attitude that Sturgeon's law applies to pretty much everything. So 80 or 90% of AI stuff is going to be crap. There's a lot of hype and all the rest of it. So that will apply. But I do think that AI has some real gold nuggets under the crap. As opposed to, say, blockchain, where there was nothing there. It was just entirely crap all the way down. That's probably offended some people in the audience, and I don't care. It really is crap. But with AI, there's some genuine gold nuggets in there. One area that I do think is one of the most exciting ones for me is in the area of legacy modernization. A few years ago, before AI really got kicking, I spent some time with one of our teams who'd been working with a client to modernize a large COBOL mainframe. Again, critical COBOL system. Our approach to legacy modernization is we avoid like the plague the idea that you can just build a new system and cut it over. That kind of cut over to a feature matching, there's a word for it.
Parity.
Feature parity, that's it. See, you know the words, I don't. So a feature parity system is a disaster. We've seen it fail so many times. And even if you succeed, you've made no progress, right? Because you've got feature parity. So, how exciting is that, eh? So we instead like a gradual process where you gradually build, you want to build new features, new things that are valuable to the customer, but you build them in a new environment, and then you have the hooks into the old environment so that the two can coexist. The metaphor that I kind of used once and it caught on, that actually came up while I was in Australia, up in Queensland, and I'm looking at the big strangler figs. And said it's like that. You've got this new system that's coming in, gradually taking over the old system, and eventually the old system will die and the new system will just be on its own. So that's the approach we like to try and take. And they were doing this with the mainframe systems. And the hard part of this is because finding out where are the seams in that mainframe system that we can use, that we can insert new behavior, that we can intercept events running through the system. And they went through a lot of effort identifying those seams. And it involves a lot of conversations to the business people, to people who know the existing code, looking at the code. There's a lot of study involved in doing that. So they rolled off that project, and that was about the time as AI stuff was kicking in. They then said, I wonder if any of this, we got a bit of time between our Nivis and our next project. I wonder if we could actually use AI and how that would help us. So one of the things they did is they said, well, we can take all the source code and we can turn it into an AST, and we can throw that AST into a knowledge graph. And then we can use a ChatGPT-based thing to interrogate that knowledge graph. Because, we don't want to be writing graph queries. It's too hard. But we can get a chatbot and use a RAG-based idea of, ask a question, it can find out the relevant bits of the knowledge graph and then give us an answer and point us to the bits of code. So I can say, here's this bit of data over here. I see this report over here. Well, how do we get from this data here to this report here? Where are any of the calculations going on? And it can actually go and tell us how it works and point us to the lines of code. And then maybe we can go further. Maybe we can say, well, how did this appear? Where's the requirements documents? Where's the email chats? Confluence. We could finally find a use for Confluence and find the Confluence data and get that in there as well. So we can get all of this stuff and we can use that to enrich our knowledge of things. And then also maybe we can use these seams that we're beginning to form in there and use them to create telemetry, wide logs coming out of the seams. And we can put that into the knowledge graph as well and see how the system's actually behaving to realize, that's actually not happening there because somebody put a patch on that and then somebody put a patch on top of that and we didn't see those patches, but we can see evidence of them from the telemetry. So that's the direction that we're heading. We've built an internal tool that we call Code Concise. We're not a product company. That tool will hopefully be completely replaced by proper products in the course of the next few years. But we've learned how to use it and how to do it, which is the important thing. Because whenever you're building these kinds of tools, if you're not a full-on product company, you're always going to be throwing those tools away. But the learning, you never throw away. That's the learning that counts. So we've been doing that, and they're already seeing it's significantly faster that they can begin to understand the system, figure out where the seams go, figure out how to manipulate stuff in that area. And I think that is a really exciting use of AI in software development because we've got so much legacy systems that we are being hampered by that we need to improve. And we won't need to improve them in this gradual way, not the cutover way. And I think this is going to be a great tool to help us. And it's also where the tool is best. Yep. AI is very good at coming up with first drafts. You made the comment, there should always be a human in the loop, right? And this is exactly that kind of understanding that it can give us.
I think it is early days, but that's a really exciting use case for this type of technology. And the same techniques that we could use for legacy modernization, I've been talking to Peter Barnes about this, is a lot of organizations spend a lot of money on compliance and regulations. You know, compliance and regulations will change over here. Where in the code do we need to go and modify that to conform with these? I think using those graph representations will streamline that process and hopefully reduce that cost. And, you know, if there's any banks in the room, they'll probably be nodding their head. They spend a lot of money on code compliance and then implementing that into code. So hopefully there's something coming out of that soon. Software developers are having to embrace Copilot and other tools like Cursor and Klein and all of these prompt-to-code systems. Thinking back to my days as an early engineer, I probably would have used them a lot to get me up to speed, but there's risks in, you know, learning the wrong things and not maybe focusing on the things that are actually important, which is the principles that you need to understand to then leverage into a particular language. How would you advise people sort of thinking about coding these days, and how should they be leveraging these AI tools? Is it a sparring partner, a companion? Is it a tutor or an educator? Where do these things sit for you?
Again, caveat, still learning how to do this, early days, et cetera, et cetera. So some of the things I'm hearing at the moment, tools like Copilot, people are very lukewarm about. That's the consistent message I'm hearing. Doesn't do that much. Personal experience bore that out. I mean, I took a while to get around to it because I didn't want the hassle of installing it. I finally got around to installing it. It's actually much easier than I thought it was going to be. And of course, me being me, it's installed as an Emacs plugin because I live in Emacs. Don't judge me. I'm old. But Emacs is the best editor. You all don't understand this. I fired it up. Once or twice, I would look at its suggestions and go, wow, that's exactly what I would have typed. But most of the time, it came up with stuff and I said, no, go away. It's useless. And I ended up turning it off. Mm-hmm. So I can kind of see that for Copilot. I'm very interested in some of this prompting approach where people use prompts. I was chatting with one of our colleagues in India. He said, you know, he was knocking up a UI for an existing system. He said, I've been wanting to do this for ages, but, you know, it was just going to be too much hassle. But I thought, well, you know, give it a knockabout with the AI. And it did go really well, did go fairly fast. But the key thing is he was always looking at the code it was tossing up and saying, nah, this isn't quite right. Telling the AI, now fix this, change this over here. So he's using his experience as a very senior developer to guide the AI to the kind of solution that he wanted. Because, as he said, the source of truth is the code, not the prompts. Because even if you give the same prompts to the AI, it's not going to give you the same code back. There's no determinism here. So the code has to still be the concrete thing. So you've still got to make sure the code is every bit as good as it was. Chatting with another senior guy, Mike Mason, our global AI super dude. That's not his official title.
It should be.
It would be a good one, yes. So he spends a bit of his spare time doing coding on flight aid thing, because he's into flying, or at least he was into flying. And he says he finds it particularly handy when working with a new framework or environment, because he can ask questions of the tool and it can help him along. But again, it's providing ideas and a first draft. He's then critically applying that using his experience. That's the issue for younger developers, right? Because they don't have that experience. So I think AI can be, again, a great source of ideas and lead people to think of things they otherwise wouldn't have thought of. Yeah. But you still need that seasoning that says, yeah, 80% of your ideas actually aren't that good, but you'll get there faster as a result of seeing them. And that's the area where we most have to be concerned about. I mean, we've always worried about the copy-paste from Stack Overflow as a real problem, people not understanding that the code that they're putting in. That's obviously going to get much worse with these tools. So, and certainly what I do is, and I use ChatGPT to help me understand, you know, sometimes I'll say, I need this Emacs function, and I can't, I can ask ChatGPT to write it for me, and I've had good success with that. But the key is I always look at every line of that code and say, let me understand what it's doing. And in particular, I do this because I want to learn. Oh, I didn't know that piece of that function existed. That's a really handy function. Oh, that's how you do this. I need to learn from the stuff that ChatGPT is doing. And that's the same with Stack Overflow. You look at the Stack Overflow answer, you look at it and you say, why are they doing it the way they do? And they usually have some explanation to help you. You want to use the AI as a learning tool, but you need to be suspicious of it because it's gullible, it's way overconfident. So you have to treat it carefully, but you can learn a lot from it. But make sure that and this is not just true of code. If you're doing a presentation, if you're writing, you're using ChatGPT anyway, always reflect on what it's giving you. Use it as a learning tool and primarily think of it as a source of ideas rather than the source of final product.
That's a really great answer. So switching gears now to the application of AI inside large organizations. So a lot of people in this room have probably spent money building data platforms. They might have a developer experience platform. Now we're seeing this new thing emerge, which is a combination of both, and people are calling it an AI platform. How do organizations think about even building something like that? Do they just go and leverage cloud native services? Or do they abstract those away a little bit and provide some sort of governance and observability functionality? How do people think about building platforms today with all of these tools that are emerging all the time?
Well, the way I tend to think about platforms, and I'm very strongly actually influenced in this by a Melbourne ex-colleague of mine, Evan Botcher, who wrote an article. You can find it on martinfowler.com. Called What I Think About When I Think About Platforms. And it's a very influential article. I mean, I've run into books written by people who reference that as one of the key articles that helped frame their thinking. And so if I have anything that's in contrast with what Evan says, believe Evan, not me, because he's much better at this. But the way I think about platforms is, when it comes to organizing people in development organizations, we've always had this sense of, if I've got a whole load of people, how do I divide them up into groups that they can work together effectively? A very common way to do this is what I think of as activity-oriented division. The terminology is coming from Shriram Narayan, another former colleague of ours. And activity is basically dividing people up by their skills and abilities. So all the business analysts, all the database people, all the front-end developers, all the back-end developers, etc. But the problem is, to get anything done, you need a bunch of these skills. And if you're crossing organizational boundaries to get these people, things move really, really slowly. And you really notice this. I mean, the software development, particularly, two areas, always a contrast between application developers and database people, where, the database people are hiding in this room down in the cellar behind the door with a sign on it that says, beware of the leopard. And then testing. If you can't test your own code and you're not testing your own code, you've got such a slow feedback loop to figure out where the problems are, because testing people are divided. So what Shriram recommends, and what I recommend, is you move more towards an outcome-based division, where you say, okay, there's some particular customer valuable functionality here, and what I want to do is have all of the skills I need in a team that will satisfy that bit of functionality. I don't want the team to be too big. And in fact, this is sort of immortalized under the Amazon 2-pizza team. I mean, lots of people talk about 2-pizza teams to think about size, because it's the amount of people that can be fed by 2 pizzas. 2 American pizzas, of course, which are about this big. So there we are. But size has been what people have focused on. But what they didn't focus on is an equally important aspect, which is every 2-pizza team needs to have a particular customer need and customer interaction that they're focused on satisfying. And that customer-driven thing is the crucial part of it. So once you begin to have teams that are outcome-oriented, focused on a customer need, then you can say, okay, go off and build stuff. But the problem then is they will find themselves running into common problems. 5 different teams will all have to handle authentication or talking to this legacy system or this or that. And they end up having to everybody building it their own. Obviously, it's a waste of effort. It's frustrating. It's also should be really annoying to these teams because they want to focus on the customer product. They don't want to be focusing on all this crappy back-end stuff. So that's when platforms come into play. And the platforms should look around and say, oh, these 3 teams are all doing something very, very similar. Let's pull that piece of work into a common platform. Doesn't necessarily mean the platform team should actually do it. They might say, oh, this team did it. Now, it's not quite the same as what that team did, so let's take what they've done, generalize it a little bit, and then the idea is to make it easier for everybody else that follows. So the approach here is something I've written about for a long, long time. We talked about it back in the days of object-oriented frameworks. There's 2 approaches to framework or platform building. The first is you build the framework or the platform, and then you expect people to build stuff on top of it, which kind of makes sense because you build the foundations first. You build the platform before you build anything on the platform. That's intuitively sensible. It's also wrong, but it's intuitively sensible. The way in which we build a platform instead is you look for that common stuff that people are doing and you harvest it, gradually building the platform underneath the building that you're putting on top of the platform. See, it's totally counterintuitive and it totally fails with a metaphor, but that's the way to do it. You want to harvest. And then if you've got a platform team, their role is to harvest these common things out and then continue supporting that thing so that as changes come to the stuff that the platform stuff is using, you're keeping that up to date so that the product teams don't have to worry about that stuff. And they need, therefore, also to be very customer focused themselves, except their customers are these product teams. Now, if you come across the book Team Topologies, I've been mangling the words a little bit. You'll know this is the interplay between stream-aligned teams and platform teams. If you haven't come across the book Team Topologies, go and get it because it's an excellent book. It's one of those books that I read and thought, I could have written this. I should have written this. It's so good. I wanted to write this, but they wrote it and they probably would have did a better job than I would have done. Oh, well. But excellent book. And that's the interplay between stream-aligned teams and platform teams. And the platform teams have to have that customer-oriented mindset, but towards those stream-aligned teams. So platform teams should never be thinking, oh, we need to build this really nice capability. Whenever you know that, naughty boys. Instead, what you've got to go out and do is I go out and talk to the stream-aligned teams, find out what they need and what they're doing and what they're building, and I work with them. And if I need to enhance the platform capabilities, I don't come up with ideas in a vacuum. I come up with them because I'm being asked for them. Mm-hmm. So you have to have that going out product mindset.
We've spoken a lot about technology, and we can't have technology without people. I want to talk a little bit about people and how do we hire people? What are the attributes we should be looking for in people that, they may not be the technical skills and they know this particular framework, a higher abstraction of that. What are the attributes you would look for and what advice can you give the room?
Yeah, I actually am very worried about the state of hiring practices in the tech industry at the moment. Deeply worried about it. There are a couple of areas. I think of I know a lot of former thought workers, but that's because we've been around a long time. So some people here might remember Susie Edwards Alexander, and she's got a hiring recruiting practice in London, and she was saying it's getting really difficult to get people placed in places where I know they are the right person, but people are just not looking for the right things. Instead, what people are focused on is an excessive aim of trying to get, I want exactly these background technologies, 2 years of Databricks and 4 years of Python, and give me these exact combinations of things, and I want somebody who fits that. And they're all focused on these what do you know questions, often unrealistic combinations of what do you know. And we're finding this in our in our look with a number of our clients as well. There was one particular client we have, whose name I will not mention, where we've been having a great relationship. They've been saying, oh, we really like your people. Give us more people. Give us more people. And we would put somebody up for things. Oh, no, we want to check first who they are. Oh, they've only had 1.5 years of Databricks experience, not 2 years. So get out of them. And it was a real frustration because they were angry that we weren't able to provide enough people, and we were providing people and they were rejecting them for what we considered to be spurious reasons. And so we twisted things around a little bit and said, well, what we'll do is we'll provide this person. I know you don't think they're up to it, but let's hold them for a couple of months. And if you don't like them, we'll refund the fee or whatever. We'll take them away. It doesn't cost you anything. But if you want to keep them, then we'll keep them. And consistently, they kept them, right? Which tells me their hiring practice was wrong, right? I think of another case of a friend of mine, very experienced developer, 10, 15 years of experience, fantastic background in serverless systems, in Clojure, and really solid stuff. Going to interviews, he's getting nowhere. He had to spend 3 months studying all the kind of leaked code stuff that they asked for in interviews, so that he could answer and pass the interviews, knowing full well he's never going to do this, need any of this stuff. He says, I'm doing sorting algorithms. I don't write sort algorithms. I just use the fucking API. That's what everybody does. Why am I asked about sorting algorithms? That's where we are. It's a really depressing state. But, of course, amongst all that depression, there is opportunity. The opportunity is for organizations that know that this is stupid and can react by ignoring their stupidity, right? What do we do at Thoughtworks? We don't do, certainly hope not. I've never heard any evidence that we do leak code interviews, right? We don't look for what people know. We look for how fast can people learn things, because that's way more important. I remember back in 2000, somebody wanted an experienced C# developer, and we got, well, this guy's been doing Java for 3 years. We'll send them off. They can read a C# book on the plane, and then the client comes back and says, they're really, really good. They know how to do this. Well, it's because the core principles are the same. It's just a slightly different language. All I've got to do is learn that I've got to make the first letter of all my method calls be a capital letter, right? Because that's the worst thing switching from Java to C#. And it's the same kind of stuff here. Look for that ability to learn. And those become important. The aptitude that you have in a particular skill at the moment is, something to know about. But what's more important is your attitude to go out and do things. So I like to break down attitude, this attitude thing in 3 areas. Your customer focus, I've talked about the importance of that already. Your ability to collaborate with other people, because you're never going to know everything you need to do your job. You're going to have to collaborate with people with different backgrounds, different skills, things of that kind. Bring those in. And then your curiosity. You should always be looking to learn. That's why AI is wonderful as a learning tool if you're curious, because you're always going, why did it suggest doing that? What's going on there? And that question will lead you to improving. That's what people should be hiring for, those kinds of attitudinal things. And when I always talk about this, I go back to an old Thoughtworks cards that talked about aptitude, attitude, and the most important element, integrity. Make sure you hire for people who are people you can trust, people who will do what they say, people who aren't sort of doing dirty tricks behind people's backs and the like. Because when you can build a trusting organization of people who know that they can collaborate together effectively, then all sorts of extra barriers and complexities can go away because you can trust the people you work with. And it leads to a whole different environment. So those are the things to look for. The technical skills really don't matter that much if the people are quick learners. But the attitude, the integrity, those are golden. And there's another opportunity. I don't know. Hopefully this is not as big an opportunity for you in Australia as it is increasingly in America. But now that the Silicon Valley programmer culture has really got strong in the US, there's a fantastic opportunity for people like us who value diversity. Creating an environment that is comfortable for and inclusive for people is necessary to get that trust that I talked about, but it also means there's a huge area of hiring possibilities that are being ignored by people who are ignoring that factor. So in some ways, it's a very depressing world because we're getting a lot of bad recruitment is just dominating so much of the field. But the optimism is those who are prepared to zag at the moment, they are in a position where they can really get a lot of good people. Just look for the right things.
That's some really great advice. Thank you. I might open it up to questions from the room. I'm sure you've got a bunch of things you always wanted to ask Martin. Does anyone have anything?
Hello. Yes, here we go. All right, so I'm Ciao, just like an Italian saying Ciao, that's me. Because of my name, I met a lot of people near Italy. That is good. So I really like your talking. I'm a data scientist. I'm really inspired by your talking. I'm actually looking for a open opportunity. However, I suffer from whatever you just talked. So it was a big problem that I have to talk about people that I say, hey, I solved this problem. I have this neural network. I was just trying to dive deeply into the algorithm, say, if I set everything to 0, what's going to happen? So I have like, all of the food with mathematics equations and stuff. Nobody cares. Can you actually have the experience with Databricks for 3 years? I'm like, oh no, it's a new thing for me. Exactly, I'm actually suffering from that. But then when I talk to people, they find they wanted to do the customer-focused products. So which means they want to make money immediately. Wow, actually, most of our AI field, we have achieved a lot that we know, but this is for assistant kind of job. It's like a learning tool, help people learning, or help the employees to improve the workflow, improve the efficiency. It's like a doctor. If you consider you have some CT scan, you see, does this person have cancer or not? Now you have 1,000 patients per day. So you probably do not have time to look at each of them. It's going to be very slow. Patients have to wait for months to get into the queue. So now you have this tool, help the doctor, and it's like an assistant. It's not 100% accurate, but definitely accelerate the process. So instead of one doctor have 10 patients per day, now you can have 100. So it's like a similar situation here. So my question is that when you talk about the machine learning, the AI products, 80% will fail. I was pretty upset. So maybe we understand it in a different way. Maybe you are targeting the customers that people wanted to make profits immediately, and they tried and didn't work, and they say, it's not reliable. It's just a language model. You just send the prompt, and then you just get a different answer. It's not reliable. Maybe that's the reason. Or maybe you have some other thoughts. I'm really curious about it. I want to know why would people have the feeling? Why is it that 80% of the AI products failed? Thank you.
I'm actually not surprised nor worried that 80% of AI products fail, to be honest, because this is an early learning stage, right? And I expect whenever you're in an unknown situation, most of the things you do are not going to work. But you're not going to find out the things that do work without trying lots of things and figuring out which one, and then seeing which ones work and which ones don't. So the 80% isn't surprising to me. I mean, in a situation where this situation is this new, I would expect a very high failure rate. What we need to do is to recognize we're in that situation and say, try lots of things, create feedback loops so that we can quickly learn what's succeeding and not, discard the stuff that's not succeeding, work on the stuff that is. In that kind of environment where we're exploring a new territory, we expect that kind of thing to happen. And the crucial thing then is rapid feedback loops, rapid learning, and trying lots of stuff, and trying stuff that you don't think will work, because sometimes you'll be surprised. And if you're trying something that you don't think will work and nobody else thinks will work, and it will work, well, that's one hell of a discovery.
Thanks for your question. Do we have any other questions? If not, I'll pick on people.
Hi. That was a fabulous talk. Thank you, Martin. I loved the last question the most around hiring people and, human beings being really important. And I'm a mother of a daughter, and I often wonder about biases. And there's so much literature about, I'm like a 5-foot Asian. I can rarely sit on seats with my foot on the floor. So there's so many things which don't account for, diversity. And then I think about AI systems and how we all have a role in sort of informing and looking for biases, but also then, I don't know, in the different roles we play, correcting for it. Do you have any advice in that area on what we can do and as technologists, but also as users of AI systems?
Yeah, it's one of the things to bear in mind. AI systems are very good at reinforcing the existing biases because that's what they're learning from, right? And that's something we have to be aware of as technologists, that the AI systems that we build, or any kind of computer system, doesn't reinforce existing biases. And that's an important part of the responsible tech mission that Lily was talking about. That's part of our duty as software developers, is to recognize that this will happen, that bias stuff is inevitable, and to look for ways to detect it and to counter it. And again, it comes back to feedback loops. How do we detect the feedback loop to detect when bias is happening, the kinds of biases that are happening, so that we can spot it early and we can take corrective measures? We use techniques like guardrails, evals, and things of that kind become really important as how we do that. And then also at a human level, when it comes to our recruiting practices and things of kinds, we must be always looking to say, how can we counteract our own internal biases? I mean, I have them as well. I have my lizard brain, and I've often detected it sort of picking out a bias. And I'm sure there's plenty of cases where I've said things and done things and the bias has been there and I didn't even spot it because I know it's there. But doesn't mean we can't improve and get better, and we can't look for environments that encourage that. One of the reasons I've stayed with Thoughtworks for 25 odd years is the fact that we make that a conscious part of our organization. It's been there right from the very beginning because it was something that our founder cared about a huge amount. And it's something that is shared very much by the leadership of the organization. We want to create that kind of environment where we can counteract that kind of biases. And it's hard. When people talk about diversity, I mean, the common and incorrect statement that you often people saying, oh, it's a trade-off between high skill and diversity. That's bollocks. But there is a trade-off involved to get diversity, and it's the effort of finding people. And if you want a diverse organization, it means I have to go and find the candidates that are outside the usual area. And I have to work at that. And it is more work to do that. There's no doubt about it. But the benefit of doing that is obviously you will find people that otherwise get overlooked. That's really helpful and creates a more diverse organization. And then you get a positive feedback loop. The more diverse your organization is, the easier it is to find more people because they'll look around and say, oh, this is unusual. I don't normally see across an organization this diverse. I'll fit in much better. And they can also, of course, then lead you to more people. So you've got a fantastic positive feedback loop that can occur. So another thing I would say is look for such organizations. Look for organizations that are trying to do this and making that effort. I've mentioned her already about observability. Charity Majors, who's quite a loud voice on the internet. So I don't know how many people have come across her work. She does fantastic work on observability. She also has very recently written an excellent article about diversity and how she says that it's also a great signal for an organization's culture. If you're looking for an organization that's got psychological safety, that has a high trust culture, it's very likely to be a diverse organization as well. Now, it's an imperfect signal because it's a very lagging signal. It takes a while to build it, but it's a signal. So look for that.
A great question and great answer. We've got time for one more question.
Hi, Martin, and thanks, Andy. I'm wondering if there's any tips you'd like to share on how to drive customer focus and outcome focus to positively affect that, that 80% feeling of failure rate, to address the organizational hunger for ROI and just generally make things much more awesome.
I don't know how to have any, there's no magic tips, but some things I would say. One is the organization matters. And this is where I do again recommend the team topologies stuff and the idea of focusing on these outcome-oriented, streamlined teams. I think that helps a great deal because then everybody on the team is focused on the customer need. And so having that autonomous, have all the skills, focus on the customer, I think that helps a great deal. The thing that I think often goes missing is make sure everybody on that team has customer contact all the time. I think one of the most terrible things that's happened with the software industry was this idea of, well, we can't have these geeky programmers talking to business people, right? Because how are you going to learn to talk to business people unless you're talking to them every day from the beginning of your job, right? You need to be from your day one used to talking to business people. When in my early career, I spent time at the National Health Service in the UK, I worked on a team with doctors and nurses. And, it made a huge difference. There's no way I, as a software developer, however mind-bogglingly smart I am, as Martin Fowler, blah, 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 there's no way I can have, I've got as much knowledge as a first-year medical student about medicine, right? Because it's huge. And they all speak in Latin. You think we've got bad vocabulary problems when it comes to weird vocabulary. Try medicine, right? But working with them on a day-to-day basis, I can much better understand this is what they need. This is the information that they require. This is how they want to process things. I can talk to them, try things out, and do things with them. Just as a junior developer, I could toss up ideas back and forth. That was a huge thing to make us, successful at what we were trying to do. So that matters right the way across. Make sure everybody in the team, however geeky or technical they are talking with the business people. And they will gradually learn how to have that customer focus. Another phrase of it, this is also why human contact is much more important than just documents. Nobody has ever been motivated to make a requirement specification happy, right? But if you know the people who are benefiting from your software and you want to make them more successful and you have that personal contact, that's hugely motivating. And motivation is a huge part of what makes people productive. Because if the people are motivated, they will find ways to become more productive. You'll never come up with as clever ideas as they will if you can make the motivation occur. And you can do that by having that contact.
Well, thank you so much. It's been a pleasure talking to you today, Martin. Please join me in thanking Martin for the talk. Thanks a lot.
Thank you.